Hello everybody, I'm Nick, and in the previous video I introduced you to the fantastic and brand new output caching introduced in .NET 7. However, in that video, many of you noticed that by default, the output caching mechanism is using an in-memory cache to store all the different responses. This is obviously a problem because when you're scaling out your application, meaning you're having multiple instances of it running at the same time in parallel and then load balancing them, each instance will have its own cache, making it not only less efficient, but also you might get out of sync with different caches. So in this video, I'm going to show you how you can integrate a third-party storage for your cache. In this case, we're going to use Redis because it's incredibly fast and super efficient. If you like that type of content and you want to see more, make sure you subscribe, ring the notification bell, and for more training, check out nickchapsas.com. All right, so let me show you what I have here. So where we left off in the last video is something like this. I'm going to just run the API just to show you where we are, and then I'm going to show you the code. But I do highly recommend you watch that video too, because it introduces you to everything that the cache can do. So I have the API running, and if I go to Postman, I can go in this API and create a user. Previously, there was no users in the system. And this, by the way, is using a real Postgres database. It is not an in-memory database. So I just created myself. I can get that ID and I can get myself based on that ID. As you can see, if the ID is invalid, then I am not getting anything. I'm getting a 404 not found. And if I get all customers, I am the only customer in the system. And then I can delete a user as well by using the ID if I wanted to. Now let's see what the code for this looks like. So currently we have a minimal API with a post, a get by ID, a get all, an update, and a delete. Where we left off is that we added the add output cache and use output cache calls that adds the services and the middleware for the caching. And now what this does, if I go over here and set a bunch of breakpoints, one here and one in the get all call, and if I just run this, if I go over here and try to get myself by ID, as you can see, I do hit that breakpoint when I first call this method, but then if I call it again, I'm not getting it. The value has been cached, the response, the whole response with the status code and the body has been cached, and it's being returned by that in-memory cache. However, I did tag this cached response, which means that when I evict or invalidate that cached response, it all goes away and it can be recached. For example, when a new customer is added in the system, I'm evicting anything tagged with customers. And if I delete a user, I do evict them as well, because there is the get all response, meaning that whatever has been cached here will change when you add, update, or delete customers. Now, I could be even more efficient with my approach here because, for example, over here, when I'm caching a single ID user response, that thing doesn't really need to be invalidated when any other user is invalidated for individual responses. But I don't want to go too deep in this because I want to focus on the Redis integration instead. So by default, as we know, this is using an in-memory cache. But where is that cache? Well, here's how I would think about this, because remember, there is no real documentation for how this thing works yet. Nothing is in the docs. There's no official support for Redis from Microsoft. We kind of have to figure out this ourselves. So the first thing I would do is I would go to this add output cache call and I would elf12 in Rider to see exactly what's happening here. So I have a bunch of add transient and add singleton calls. One is adding some options. The other one is adding the object pool provider. Now, this is something very interesting that we won't really focus on this video at all, but it is something I want to make a dedicated video on, but you can just ignore it. It doesn't really look relevant to what we're doing. But then you have this thing over here, the output cache store. This interface seems to be registered with a memory output cache store. And if I go in that, then I can see an in-memory iMemory cache of .NET, and then a dictionary with a hash set for all the tagged entities, and then a lock. And I'm assuming the lock is used to prevent multiple threads setting and evicting the cache at the same time, as you can see here. So from what I can tell, what I really need to do is write a method that adds, instead of this ioutput cache store, the ioutput cache store of Redis, which doesn't exist, and we will write it. So let's start by creating a new directory, and I'm going to call that caching. Here we go. And the first thing I want to create is a new Redis output cache store. There we go. And that, of course, is going to implement the ioutput cache store, and we're going to implement all three missing members. And as you can see, we really just have three methods to implement here. Evict by tag async, which is actually going to be the last method we implement. And then we have the get and the set. Obviously, the get based on the key returns a value that matches that key. The set sets it in the cache, in this case Redis, and then evict just removes it based on the tag. So what I need to do to use Redis is, of course, to have Redis running, and I'm already doing that. I have a Docker Compose file over here that runs my Postgres database and my Redis database over here. So those are running, and I do have a browsing tool to see what the values are in my Redis database when I eventually have some in there. And now what I need to do is use the Stack Exchange Redis package. So I'm gonna go ahead and install that. And now I just need to do a bit of wiring up. So I'm gonna go over here and say builder.services.add singleton I connection multiplexer, which is what that Redis thing is using. And I'm going to say connection multiplexer .connect, and in my case everything is localhost, so I'm just gonna say localhost, and that's it. And now I can simply go here and say private read-only I connection multiplexer and use that, and this will return a database reference that I can use to call Redis. Now if I go over here to the add output cache, it would make sense for me, just because I'm playing around, to do something like this. Copy that method as it is, and then go ahead and create a new class called Redis output cache service collection extensions, and then make that static, and then paste a version of it here, add everything, and then change this to add Redis output cache and start playing around. However, this memory output cache store is not something that is public, and this one is internal, so I can't really do that. So my way of thinking is, how much of this can I just internally call and say services.add output cache, and then add everything that this method is adding, and then delete everything, and the only thing that I need to replace is this one. So what I'm going to say is services.remove all that match the output cache store. That's it. And then what I need to do is say services.add singleton I output cache store is my Redis output cache store. And really that's it. Now, if I want the overload that also adds the options over here, I can do that. I can just grab that again, put it here, and then effectively just do the same thing. Move this one here. It will remove that other one, and just duplicate this one just for good measure. And that's it. We have the methods that do the registration. Let me just rename that as well. And we'll remove the old in-memory cache and add the new Redis cache. So now I can go in here and say add Redis output cache. And all that's really left for me to do is implement the get, the set, and the evict by tag async methods, which are actually surprisingly simple. Now, before I implement those methods, I actually just want to go to the in-memory version of it to see if there's anything interesting for me. So I have these argument null exception calls, which I'm actually going to use as well, just to safeguard against null values here. And then I see the locking, which I'm definitely not going to implement in this video. It is definitely possible, so you can take that code and implement it yourselves if you want to, but Redis can get a bit complicated with that. So I want to focus on just adding the functionality, and then you can take it and extend it in any way you want. Eventually, I think either Microsoft or someone else will actually implement a proper version of this Redis implementation, but we don't know until .NET 7 is fully out yet. So with all that, all I really need to do is copy that and paste it here, copy that and paste it here, but without this one, and then copy that and paste it here with that. All right, and we can close all that now. So Redis works surprisingly easily. So we need to get a reference to the database. So all we need to say is multiplexer.get database. By default, it gives you database 0. You're gonna see we're gonna have a bunch of them in the call. And then all I need to say is return await and make this async. So I can say await db.string get async, and the key is that here we go. And that's really all we need to have for the get implementation. Now the set is just a little bit longer, which makes sense because we also have the tags to deal with, but even that is very, very simple. First, we want to iterate over all the tags. So we're going to say tags over here, tag, and in case those are null, I'm going to say array.empty string over here, just so I don't iterate for any of them. And then I'm going to add them in a set in Redis. So they're going to be stored basically as a list, which I can deal with. So I'm going to say await db set add async. I'm going to add the tag and the key over here. So I'm going to associate a tag with a given key so I can actually invalidate all the keys with that tag later in an efficient way. And this, of course, needs to be async, and then I need to add the actual value as well as a string. So db string set async, and then key value and the valid for parameter for the automatic invalidation of the item when it falls out of the time to live that we pass down from the call. And the last thing we need is the evict by tag. When someone says evict anything tagged with this given thing, we want to remove it. What we're really going to do there is get anything that is in the customer's set and then call the method that deletes everything by key in Redis. So same thing as before, we're going to get a db reference. Then we're going to get all the cached keys by using the db.set members async, which gives me all the members of a set, and the set has the tag as the identifier. So I'm going to change that to async. Then I'm just going to say keys equals cached keys dot select, and we're going to select all those values as Redis keys, and it's going to work as a conversion just like that because of the operators it has. And then I'm going to just very naively, if you want, concatenate the individual item as well, the tag itself, because we want to remove that as well. I'm going to say to array, and of course that tag needs to be a Redis key as well. And then in the end, all I need to say is db.key delete async and pass down all the keys, and with a single call we can delete it. And that's it. Now we have a Redis provider for our cache. I'm going to just add the missing semicolon here, and I really don't think I need anything else. So what I'm going to do is just run this API, and I'm going to first add a breakpoint to, where should I add it? Let's add one to the get all and the get by ID ones, and I'm going to add one here as well to the get all set, and let's add to the evict as well. So let's go ahead and get all customers in the system. So what's going to happen is first the Redis output cache store, the method called getAsync is being called with the key which is generated by the output caching mechanism. It gets a reference to the database, and then it tries to get the string. Because the value was not found, we're coming in the minimal API method now. Now it gets that single customer and it returns the response. So what's going to happen is then it's going to set the value in this case, Redis. So it's going to use all the tags to set it, and it's doing that now, and then set the actual value and return it. Meaning I can actually go here in my Redis viewer now, if I click that, and I can see both the set with the item, but also the individual response cached over here with the body in base 64. Meaning that if I call it again, it's going to go to the get method, it's going to find the response, and as you can see, it did not go in the minimal API, just returned it from the cache, and it's going to do it again over here as well. And that all works fine. Now, if I want to invalidate the cache, maybe because I create the new user, I can do that. I'm going to evict the cache. The evict by tag async method is called, going to get all the items in that set. In this case, it was only one, and then it's going to concatenate it to have two keys, the customer's tag and the key of that single item that has been cached, and then call that delete. And if we go back in the Redis viewer and refresh, there is nothing here. Everything has been cleared up. So the cache has been successfully evicted. And really that's it. That's all you need to get started and have Redis as your backing cache for the output caching mechanism that .NET 7 adds. Now, things can get a bit more complicated depending on how much traffic you have and how many things you're caching. And that's where that locking mechanism might come relevant, but not everyone really kind of needs that. It depends on how far back your cache can be stale and outdated. And for that reason, I'm not going to really implement that as part of this video. Maybe I'm going to do it in live stream just as a bit of an exercise. But for now, that's all I had for you for this video. Thank you very much for watching. Special thanks to my Patreons for making these videos possible. If you want to support me as well, you're going to find the link in the description down below. Leave a like if you like this video, subscribe, I'm not going to like this and ring the bell as well. And I'll see you in the next video. Keep coding.